Hello, my name is Dr. Abrahamian, and in this channel I focus on math competition problems. The problem that I want to go over in this video is motivated by a problem from Berkeley Math Tournament in 2025. Find all associative binary operations star on the set of positive integers for which we have this equality. If you take y and star with itself x times, you get x plus y plus xy. Okay, so I'm going to walk you through the process of obtaining the solution. The first thing that I did was I looked at the right side and I saw a factorization on the right side. So I can write this down as x plus 1 times y plus 1 minus 1. This is going to be a little bit easier to deal with. So now let's just start with plug in some values and see what we get. For example, if you plug in 1 star 1, you have y is 1 and x is also 1. So this would be 1 plus 1 times 1 plus 1 minus 1, and this is 4 minus 1, so that is 3. We can plug in x star x and see what we get. So this would be x plus 1 times 1 plus 1 minus 1. So this would be 2x plus 1. Now the next thing that I notice is that if I look at the left-hand side of this equality, I can use associativity of this binary operation, and I can break down this expression into two different pieces. For example, if I have y star y, and I take this one a times, so a stars here, and I start this one with y star y, and then I have b stars here, I can evaluate this one in two different ways. I can write this down as the first one is y plus 1 times a plus 1 minus 1 star, and the second one is y plus 1 times b plus 1 minus 1. On the other hand, I can say this is equal to, well, this whole thing would have a plus b plus 1 stars because we have one star in the middle. So we can write this down as y plus 1 times a plus b plus 2 minus 1. Now, if I have two numbers m and n, this is m and this is n, then if m and n can be written in that form, then I can write down what m star n is. So if m is equal to y plus 1 times a plus 1 minus 1, and n equals y plus 1 times b plus 1 minus 1, then m star n is equal to y plus 1 times a plus b plus 2 minus 1. Let's see if I can relate this one with m and n. I can distribute this. I would get y plus 1 times a plus 1 plus y plus 1 times b plus 1, and then minus 1. Now, this guy is m plus 1. The other guy is n plus 1, and then minus 1. So this is m plus n plus 1. So I'm guessing that, in fact, m star n equals m plus n plus 1 is in fact the answer to the problem. Now let's see if it satisfies the two properties. So first, let's see if it is associative. So let's evaluate this. This is m plus n plus 1 star k, which is m plus n plus 1 plus k plus 1. So that's m plus n plus k plus 2. And if you evaluate m star n star k, you would get m star n plus k plus 1, which is m plus n plus k plus 1 plus 1, which is exactly what we wanted. So this is in fact associative. Now let's take y and start with itself x times and see what we get. So y star x times, and this is basically x stars. So let's see what we do here. So because there are x stars, there are x plus 1 y's. So what we do here is we're adding y to itself x plus 1 times, and then we are adding exactly x ones. Each of the stars gives me an additional 1. This is exactly x plus 1 times y plus 1 minus 1. So this does satisfy the properties that they gave us. Now, Let's see if this in fact is the only binary operation that satisfies the two conditions. Let's see what this condition tells us. Well, this condition tells us that n plus 1, so here is the summary of what we did. If n plus 1 is y plus 1 times a plus 1, and m plus 1 is equal to y plus 1 times b plus 1, then we can say m star n is m plus n plus 1. Now, what does this condition give us, these two conditions? Well, they tell us that there is a common factor of y plus 1 between the two. So in other words, if GCD of m plus 1 and n plus 1 is more than 1, then in fact we can say m star n is m plus n plus 1. But if this GCD is not 1, then how can we evaluate m star n? So for example, let's say m plus 1 is 5 and n plus 1 is 7. If I want to evaluate 4 star 6, then one way would be to think about how we can break down this 4 and 6 into stars. In order to write down 4 as y star y x times, what do I really need? I need 5 to be x plus 1 times y plus 1. And that's really not possible. So I can't really break down 4 into smaller pieces. And I can't do 6 either. 6 equals y star y. And this is x stars. This is x stars, gives me some similar situation, and because 5 and 7 are primed, you can't really get that. In other words, if I want to evaluate for star 6, I can't go down, I have to go up. So I'll start from 4 star 6 and I'll start it with more 6s, and that ended up giving me the solution. So suppose we want to evaluate a star b. So let x be a star b. So I want to see what is that a star b. So here's what I'm going to do. I'm going to take this x and I'm going to star a bunch of b's to that. Let's say there are n minus 1 stars. So this is the same as a star b, and this one would be n stars. Now let's write down both sides and see what we get. The left side would be x star. Well, this one is n minus 1 plus 1 times b plus 1 minus 1, and that's equal to a star. The right side is n plus 1 times b plus 1 minus 1. So let's see what this is. This is x star n times b plus 1 minus 1 equals a star n plus 1 times b plus 1 minus 1. I can evaluate the left side and the right side if I have these conditions. So if GCD of x plus 1 and n times b plus 1 is more than 1, and GCD of a plus 1 and n plus 1 b plus 1 is more than 1, then both sides can be evaluated, and then that way we can actually find the answer. So the left side is x plus n times b plus 1 minus 1 plus 1, and the right side is a plus n plus 1 times b plus 1 minus 1 plus 1. And once we simplify this, we can evaluate x as a plus b plus 1, which means a star b is in fact a plus b plus 1. So now let's see if there is an n satisfying these two conditions. So what do we need? We need GCD of x plus 1 n b plus 1 to be more than 1, and GCD of a plus 1 n plus 1 b plus 1 to be more than 1 as well. Now, we are assuming that a plus 1 and b plus 1 do not have any common factor, because if they do, then we can easily find x. So if GCD of a plus 1 and b plus 1 is more than 1, then x would be a plus b plus 1. This is something we did earlier. So I need to be able to find some n that n plus 1 and a plus 1 have a common factor, and probably also something that n and x plus 1 also have a common factor. So that one can be done in some instances. So if there are primes p and q such that they're distinct primes, p divides a plus 1 and q divides x plus 1, then I can say n is 0 mod p, n is negative 1 mod, or rather the first one is mod q, the second one is mod p. So this has a solution. This is by the Chinese remainder theorem. And if I can find a solution for that, then I'm done. So let's assume that is not the case. Otherwise, if that's not the case, so that means a plus 1 has only one prime factor, and x plus 1 is also exactly the same prime factor. So it's p to the power of k, and x plus 1 is p to the power of l for some prime p. But if we do the exact same process, but starting by a's from the left, we get, so similarly, we obtain x plus 1 is equal to p to the l, and b plus 1 is p to the s, which means GCD of a and a plus 1 and b plus 1 is more than 1, which is again exactly a star b equals a plus b plus 1. So to summarize, the only solution is a star b equals a plus b plus 1. And that brings me to the end of this video. So I will see you in the next video.